Okay, I guess we'll get started then. Hello, everyone. Welcome to AI with MIT App Inventor. Selim, Tezel, and myself will be presenting. My name is Karen Lang. I am a former member of the App Inventor team. I was with them for 5 years on the ed team. Prior to that, I was a CS high school teacher for 20 years. And right now I'm working with Technovation as a curriculum developer. And I'll let Selim introduce himself.
Greetings, everybody. My name is Selim Tezel. I'm a member of the education team at MIT App Inventor. This is my 3rd year. Before MIT, I was a member of the EDC Beauty and Joy of Computing project. And before that, about 20 years, I was also a high school teacher, math and computer science. Now, the slides that you're going to see here are all in this bit.ly address that you can find. And maybe Karen will be kind to copy paste or put that also on the chat. That'll be wonderful. And
also the if you scroll down on the session page, the slides are embedded there.
Beautiful.
But I think that's good. Okay, and just to cover the session norms, I guess we should go over this. All sessions are being recorded, so you should be aware of that. You are a viewer, and so if you want to interact with either of us as we're presenting, use the chat, please. One of us will be monitoring it while the other one is speaking. And if you do want to join on screen, keep your microphone muted when you're not speaking. And videos are recommended, but is optional. And of course, remain professional and respectful.
All righty. So I posted the poll, Karen. I'm not able to see if everybody can access that. So maybe we could request everybody to fill that. I don't quite know how many people have App Inventor background, but that poll will be helpful. So let me get started. Now, we don't know who's going to be watching this video after the conference, so it is possible that some people have never had App Inventor background. So with your permission, I'm going to very quickly summarize App Inventor coding environment. As some of you already probably know, App Inventor is a completely visual coding environment. On the left here, you see what is called the designer. This is where you design the app, the graphical user interface. At the very left, there's a components palette where you can drag and drop pretty much every component that you would need to create an app. Buttons, text boxes, password text boxes, labels, etc. And as you drop and drag and drop them, you'll see the graphical user interface built gradually here. And in the next panel here, you have the components hierarchy, which gives you a sense of how the components relate to one another, what's the embedding structure, etc. And on the right panel here are the properties where you could, for example, change the the text of a button, etc. These are all available here in the designer. Now, when you press the upper right corner here where it says blocks, you will come to the actual coding environment. And as you see, everything is block-based. It is very much like Scratch, where you put a puzzle. It's like puzzle pieces fitting them together. You have some built-in blocks here that are available, control, if then, etc., logic blocks, math block, text block, etc. But also based on the components that you have chosen to drag and drop, there are associated blocks that go with them. And when you put these blocks together, certain blocks will not fit with each other. That basically makes making a syntax error practically impossible, and that's sort of why this coding environment is very attractive to beginning users. Now, pretty much everything we're going to be talking today all the tutorials are available from our website at appinventor.mit.edu. If you go to that page, somewhere in the middle, you will see a little region where it says Artificial Intelligence with App Inventor. And when you click on them, you'll come to a page with all the tutorials that we're going to be talking about today. So that is quite easily accessible after the workshop. Okay? Now, the App Inventor AI projects are roughly categorized into two groups. The first group is called rule-based AI projects. These are what you would call classical AI projects, sort of like from 70s, 80s, etc., where you define some rules and basically machine, with the help of some conditionals, etc., understand how to follow those rules. The second type of projects are machine learning-based AI projects, and I will present them to you in a few minutes. Now, for the rule-based AI projects, the first project we have is called Therapist Bot. This is inspired by a publication by our collaborators, YR Media, called Could Your Next Therapist Be Your Phone? And it is based on MIT Professor Weizenbaum's ELIZA project from the 1960s. You may have seen this in a computer class or something like that. And the idea here is it uses what is called Carl Rogers' non-directive psychotherapy, where the therapist bot never directs the conversation, but asks questions so that the user of the app will elaborate on a statement that they have given. And here you can see an example conversation. The user says something and then the bot responds. Now, just to give you an idea how this works, so let's imagine that during the quote-unquote therapy session, the user said something like, "I always loved my sister." Now, the bot has to parse and make some sense of this sentence. So the response the bot gives starts with a qualifier like, "Can you explain why?" And the words "I" and "my" are replaced with the words "you" and "your" to get the response, "Can you explain why you always loved your sister?" So it is a non-directive style of psychotherapy where we invite the user to elaborate on some statements that they have made. Now, this is one of those projects. It was the first occasion for us to introduce in App Inventor a new data structure called dictionary data structure, and it's a very natural context for this data structure. Here you can see key value pairs, and the words "I," "me," "my," etc. are replaced by their corresponding words "you," "your," "yours," etc. And this project also introduces a very, very powerful text block that was actually created for this project in mind. It's called Replace All Mappings, where you can collectively replace entire sentences with the removing the keywords and replacing them with their equivalents. Okay. Now the next project we have is called Voice Calculator. The challenge that was given to us was how do you use only the native capabilities of App Inventor, so without importing any AI extensions, etc. How do you use native capabilities to create an intelligent system? It is our introduction to conversational AI agents such as Alexa and Siri. How do these agents interpret what the user is saying to them? How do they understand their intent? And how do they know how to appropriately and meaningfully respond to the user? This is not immediately obvious, but the project gives a lot of sense how you might be able to do that. At the end, you end up creating your VUI, the voice user interface, and it's a voice-driven calculator. You ask a mathematical question like, what is 73 times 51? The machine parses the sentence extract the numbers that are going to be operated on. From the language, understands that, oh, this was a multiplication intent. And then it responds meaningfully by saying, the product is 3723. Of course, most things that the user would choose to speak to the calculator, like, hello, what's your name, etc., the calculator will not know what to do with that. So the default response is, I don't understand. So it's a system that has some intelligence responses and then some default responses. Here you can see on the left a bunch of different ways of asking the question, what is 73 times 51? Everything I have in red color here is really ignorable. What matters is the numbers and the symbols used, or the words like product, multiply, times, etc. And in the program, if we have time, we might be able to give you a glimpse into that. You declare your multiplication intents, and you put the symbols and the words in English that amount to requesting a multiplication. If you look at Alexa coding, this is sort of like actually mirroring that process where intents are decided ahead of time and then used. Again, this project used a very powerful text block called the contains any block, which is able to extract and check against some keywords that you have specified. The last project we have in the rule-based AI project category is rock, paper, scissors with AI project. It is probably the most advanced AI project we have in our tutorials. It uses the context of one of the simplest children's games, rock, paper, scissors. And what happens is you create a program that allows the machine to observe and learn from the user's game choices. It uses what is called the Markov model. So here you can see the graphical user interface, and at the bottom you can see the Markov transition matrix. This matrix, I'll show in a minute, will allow the machine to become intelligent enough to repeatedly actually beat the user at the game. It is an early classical example of what is nowadays called reinforcement learning. Now, just to give you a sense how this works, so here is a Markov transition matrix. You can see the entries here, rock, paper, scissors, rock, paper, scissors. There are some numbers here. So let's look at, for example, this number 13. So this is an instant in the game, and the machine has been keeping track of how the user is playing. This 13 means the user followed their rock choice with a paper choice 13 times in the game so far, okay? So if the next time the user plays rock, the inference that the machine makes is, oh, it's most likely it's going to be followed by paper, and then to beat that, the machine obviously plays scissors. So it is a small, clever, bookkeeping, mechanism that allows the machine to learn, uses choices and then act responsibly and intelligently. So it's an example of, machine intelligence, and it's you create this from scratch. So it's a pretty powerful, I feel, tutorial. Now, when we come to machine learning based AI projects, the first example we have is image classification with what is called the look extension. It is our introduction to machine learning. The look extension classifies objects. When you hold the the app at the end of the project to an object, it will recognize that as a pen, as a lamp, as water, etc. It is based on a model that is already trained on about 1,000 objects, and this is from Google's mobile net. So these trainings has already been done, and we are basically employing that. Now, one thing about this extension is it's not terribly accurate, so you could always surprise it with an object that it has not seen before. But it gives us some opportunity to talk about things such as AI, bias in AI, AI and ethics, how AI might prove to be inaccurate, etc. The next project is called Personal Image Classifier, or PIC for short. It is inspired by Google's Teachable Machine. If you have used it, it is very similar interface. Now, unlike the earlier Look extension project, in this project, students train their own model. So you can see on the left here, I have trained a model with several classes. One where I'm showing my face, second where I'm hiding my face, and then the machine is trained on these and then learns how to classify different images. It's basically supervised learning, an example of supervised learning. And the browser-based training model uses, if you have heard about this, TensorFlow.js, again from Google's work. At the bottom here, you'll see that it's reporting confidence value. So you might show a new image after the training, and it will not be 100% confident maybe about an image, but it will report its confidence level. So that's also something we use in the project. Now, after the training, what we do is we create an app, and I'll demo this in a minute, to play peekaboo. So we are trying to draw an analogy how machine learning is not very different from babies learning. Babies need to be exposed to a lot of images, a lot of visual information before they can make sense of their environment. So after the training is done, basically if the machine, aka the baby, sees you cover your face, the baby will cry. If you show your face, the baby will smile. And you can see that there are live confidence levels. So you can see if you try to trick the machine or the baby, how those confidence levels are changing. So it's a good introduction to these concepts such as confidence levels. And again, one can discuss how AI systems are fallible, and there is AI in bias in AI. The next project is very, very similar to Personal Image Classifier. It's called Personal Audio Classifier, or PAC for short. Instead of images, this time the training is done on audio clips that are 1 or 2 seconds long. And what happens is an audio clip is transferred into a spectrogram, which is basically a visual representation of the audio clip. And then the relay system works very similar to the PIC model. Again, students create their own models, and the project here is to create an app for a secret diary that only opens to your voice. If somebody else speaks, the diary will stay locked. So this is our project. The next project is called PoseNet and Awesome Dancing with AI. We use Google's PoseNet environment, and it is used to detect and track key points of the body, wrists, elbows, shoulders, etc. And as you can see in the animation here on the right, it will basically allow you to construct a skeletal representation of the human body that is moving in real time. In this project, we also quantify some very basic dance moves, like what does it mean mathematically to have your hands in the air, to have a knee up, etc. So the app recognizes these moves and adds points to the score of the dancer. So it's a neat little project here. Now, the last project we have this year that just we finalized is called Facemesh Filter Camera Project. This is very similar to PoseNet, but instead of tracking body landmarks, it is tracking facial landmarks. And at the end of the project, students create Instagram-like face filters. Here you can see our graduate student Joy with the cat filter on her face. This was a surprisingly popular project when we did this at MIT's East Spark event with middle schoolers. They somehow liked this project a lot, so we were happily surprised about that. Now, some possible future projects, I'm going to just highlight a few of them. We have a potential collaboration, a major potential collaboration with Amazon. And what we would like to do is interface with Alexa and create apps that uses voice user interfaces and conversational AI. This project uses what is called CloudDB component in App Inventor to allow communication of Alexa with the mobile device. So we're hoping to go further in this project and make this interface public. It is currently in the beta phase. Another project which is very dear to my heart, I don't know, we're going to be able to recruit an MIT undergraduate to help us with that. Here on the left, you see the image of the MIT Computer Science Department's data center at the very left. In the middle, you see art by an artist like Picasso. And what happens is the style of the artist is transferred into the image. And here you have Stata Center recreated in the style of Picasso. I feel this could be a very fun app to have on mobile devices, and I can see this being enjoyed by students. The final one that I'm going to mention, there's some efforts at automatic text generation in App Inventor. So a project that somebody proposed is Haiku Generator app, where you have an interface that asks some questions to the user to just get some settings, mood, etc., and then generates an original haiku. So we are hoping to maybe make some progress in this area. Now, we are always looking for some ideas. We are sort of limited by what the development team is able to provide us with, but if we have some good ideas, we always are able to motivate them to create AI extensions for us. The AI extensions, I should mention this before I forget, do not work in some of the older tablets. So that's one of the reasons actually we invented the rule-based AI projects, because they don't need any AI extensions to work with. But the machine learning-based AI projects will need some of the later operating systems and devices. Alrighty, now I'm going to pause here. What we are about to do with Karen is we're going to give you an example of one of the AI projects which we feel is representative and interesting. Again, I'm not 100% confident how many people have a background in App Inventor or have devices where the AI extensions work. So I'm not sure if you can follow along. If you can follow along and do it with us, that would be amazing. We'll be very grateful if you can do that. But even if you want to just watch and just get a sense of what this is about, you're more than welcome to do that. Now, if you look at this page of the slides, I have here, it's called the Peekaboo tutorial, and there's a link. When I click on that link, it brings me to a Google Drive folder, and I put in that folder, a lot of, documents that you could use with your students. There's a PowerPoint presentation about image classification. There are 2 student guides which are going to take you step by step into what Karen and I will lead you through in a minute. There's a teacher guide. There's a completed app the AIA file of that app. There's a template of the app. What I'm going to request, actually, before we forget, if you could, go to that folder and right-click and download that template. In a minute, when Karen takes over and she starts doing the actual coding with you, you will be able to work with the template. Okay, so I'm going to just show you that it's there. Now, in a minute, we're going to be training a model. But again, because of whatever reason, if your browser doesn't allow you to use what is the classifier, and let me actually show you how to get to that. So if you go back to the slide, there's a link called HTTPS classifier App Inventor MIT edu. If you click on that, you will come to the training page, and that's what we're going to be using. If this page works for you, it's wonderful. Please go along. If it doesn't, you can download again the model that we have as a default for you. It's trained on, I believe, on me, but people have told me that it actually works for pretty much everybody. So you could also use that. Okay. Now, before we go any further, I'm going to quickly demo, and I'm going to try to wake up Visor here. Visor, you might know, is a way you can project App Inventor to your desktop. So I'm going to see. So if you can see my picture here, I'm covering my face, and the baby switches to the crying baby face. If I show my face, the baby is happy. So you cover peekaboo, and the baby smiles. And you could try different ways of covering your face. What I find fascinating is all these sort of ambiguous movements. When you're sort of like partially covering your face, you can tell how the confidence levels are changing. And at some point, the baby is not confident anymore that it is seeing you, so it switches to the crying baby. So this is the very simple app that we're going to create. And the idea is to make parallel to machine learning and how a baby learns. And that's what we're going to do. So I'm going to request, if you're following along and doing it with us, go to the classifier App Inventor MIT edu page. So it will bring you to here. And here, I hope you can see, and Karen, maybe you could give me some feedback. Are people able to see me in that little camera there?
Yes.
Okay, super. So this is a live feed of me, and here you see a little plus sign. I'm going to click on that, and I'm going to create a label for the first image class. This is the class of me showing my face. So I'm going to call it just the me class. Okay? So the first class is the me class. We'll put some samples in a minute. Let's create the second class. It's called not me. This is me hiding my face. For coding purposes in a minute, please do not leave any spaces between the words not and me, because we have some default settings there that assumes that you have this name as not me without spaces. Okay, so we created two classes. Now here I'm going to click on the menu here and select the me option, and I'm going to capture some pictures of me from different angles, different distances for the camera, etc. So let me do that. And as I do that, you can see the samples are filling up. I'm going to do about I'm going to do about 25 of these so that it doesn't take forever to train. If you made a mistake or you have too many that you want to get rid of, at the upper right corner, there is a little cross symbol, and you can eliminate some of these here. So I have now 25 examples of the me class, which is me showing my face. And then I'm going to do the same. I'm going to go to not me here, and I'm going to capture a number of images of me covering my face. And you may want to crack your fingers a little bit so you can see what you're doing. So I'm going to capture some images. I'm covering my face different ways, maybe with different hands. So we have some variety of what it means to hide your face, okay? And then you can check to see everything looks good. And if you like it, we're going to do the training. So I'm going to wait for like a minute just to make sure those folks who are doing it along are able to catch up. And I don't know, Karen, if there's any indicators in the chat, if there are any questions about this step.
No one is, okay, give us 1 minute. Yeah, I actually created a poll. So if you want to click on the polls tab on the right, just as a check how people are doing, either ready to continue, wait a minute, go back, or go back to the beginning. So if people could answer that poll, we'd get an idea of where people are.
Super, thank you. Thank you for doing that, Karen. Yep. And I'll just wait for my cue from you, Karen, when you feel we can.
See if I can share the results. Okay, I'm trying to see the results. I'm not sure where to see them. But let me just check the chat. Okay, so someone's asked to go back. They just got onto the website.
Just go through the steps. Would that be helpful?
Yeah.
Okay. So you go to classifier.appinventor.mit.edu. This is available from the slides that we have provided you. You can just click on that. When you click on that, you come to a page that looks like this. It's called training page, where you see the plus sign. If you click on that, you can create a class called me. And then if you click that again for a second time, you can create a class called not me. Sorry, Karen?
Sorry, I'm just trying to read the results of the poll. Go ahead. I think it's worth you going through it again.
Yeah. And why don't I just do this again, just so for the sake of quickly doing it. So I press the plus, I create a label called me. I press the plus again, I create another label called not me without any spaces between them. This is just a choice to be consistent with the coding. And then I'm ready to capture images, but I want to know what class am I providing images. So I click here, I select the me option, and now I'm ready to capture some images of me moving around different angles, etc. So I'm going to do that. I'm going to do 25 of these. Okay. And then when you're satisfied with it, you could examine if there's something you didn't like. You could click on this cross sign here. That will eliminate the picture. When you like it, you do the same for not me class. So you select from this menu the not me option and capture some images of you covering your face. So here are some pictures of me covering my face different ways, using maybe the other hand, etc. Okay. So I like to have about 25 of these just to make sure that the training doesn't take forever. And here is where we are. Okay. So when Karen gives me the cue, I will move to the next page.
I think we're okay.
You're okay? Super. So you have your now image classes. There are 25 samples, examples of you in the me class, and then you covering your face in the not me class. So we are ready for pressing this train button. You click on that. It's going to think for a while. If you have a lot of samples, like 50 or above, this might take quite a while, but 25 should be reasonable. It's going to be reporting a loss number. The lower that number is, the better the learning. Now we come to a testing page. In the testing page, we're going to provide the machine with some new images it hasn't seen yet. And then we're going to see if the classification it gives here is correct. So let me start.
Sorry to interrupt. There's a question that's come up and I answered it, but I may have answered it incorrectly. If they put a space in the label, is that going to cause a problem?
So when we go to coding, you're going to notice when you look at Karen's, the code that Karen is going to show you, that there is, there's reference to, it says not me. If you place in that code a space between the not me, you should be all set. It's not the end of the world.
Okay.
But if you do it with a classroom of students, you may want to just emphasize again that there's no space between, so that it's consistent with the given code. We're going to give you some code just to save you some time. But it's really not the end of the world. You could just go through the code and see wherever you see not me, just make sure you put a little space between those two. It shouldn't be a problem. Did that answer the question, Karen? Do you think?
Yeah, I think so. A few people are asking that. Yep.
Super. So now I'm going to capture a new image it hasn't seen. So here's me, and here's a new image, and observe there's a green light that lighted up in the me class. It says 99% confidence that this is me. Let me capture another one. This time let me smile. Interesting, it hasn't seen me smile before. The last time I don't think I smiled, but it still understood that this is me. So let me do a couple of these. These are all different me's. Now let me cover my face. Let's see what's going to happen. Not me became green. It's 99.6% confidence, not me. Let me do something ambiguous. I'm curious, what is it going to do? So it still thinks it's me, but the confidence level shrank to a 70%. Okay? And you can see these results at the bottom here. Let me do a couple of more hiding my face type of things. So we have some more samples there. And then you have your test results. You can scroll through and see if you like these. Now, in the event that you're happy with it, you can press the export model. That means your model is trained. It is now ready to be imported into App Inventor. If for some reason you realize there were some misclassifications, you would just go to the train button here and press that, and that will bring you to the original page where you can again do some trainings, add maybe more data, etc. Okay. Now, just to conclude this, and then I'm going to pause and ask Karen to do another poll. I'm going to show you how to export the model. You click on that, and it will create something called model.mdl. I must have had another model before, so it's called mine model 1 MDL, but it's going to be called model MDL. You do not have to rename this. You could just leave it as it is. If for some reason you did not have luck with the classifier page, you can go to the Google Drive I hinted. So by pressing the Peekaboo tutorial link here, you'll come to the Google Drive. And I have created here a default model for you. So you could also use this one if for some reason your classification process did not yield a model. So I'm going to pause here. Karen, maybe you'll be kind to give another.
So we got a couple of questions in the chat that I want to, and a few people are asking for time to try it. So someone said their students don't have webcams. So could you show in the training how to drag in pictures?
Surely. I may not have pictures of me, but I have pictures of cats and dogs. So how about I do that? How about, so I'm going to assume, this is finished. So I'm going back to the training. I'm going to just get rid of these classes. I'm going to just create a, let me create a cat class. I'm going to create a dog class. This could be pictures of your students that they have taken ahead of time. So let me see if I can find my cats and dogs. And I might have only one example of each. So it's simple as you grab the kitty and drop it into here, and it just becomes an example, a sample image for the cat. And I'll do that for the dog. If I'm not mistaken, if you had like 100 images, actually, I'm pretty sure you can do that. You can grab all of them and then I think drag all of them at once. I'm pretty confident I did that for a recycling recognition project. I had many of them. I just dropped them all at once. But that's how you would do that. And then if you have enough cats and dogs or whatever image classes you have, you can do the training in there. Okay. Now, one thing I didn't show, and I'm going to just quickly train it on this one data. It's not very good, but after you exported your model, there's an export training data button here. If you click on that, it will preserve a memory of your training data. It will be basically a zip file. It's called data.zip. So if you ever later, you did a lot of work in App Inventor a couple of weeks, and now you come back, you want to access your original training data, that's how you can upload your training data. So let me show you. One of the buttons here was upload training data. So that's, you could have done that by just grabbing that zip file and uploading that. Okay, so I'm going to pause, and Karen, kindly let me know if there are any other chat questions, or we should wait a little longer.
It came up, but I think Beryl helped. There are questions on webcam issues, but I think there's a pop-up that would say enable the webcam, and that has to be done. So if you have pop-ups blocked, you may not see it.
Yeah. I'm not sure in Zoom we had some students had to turn off their Zoom video feed before the classifier page was able to capture images. So that's something we experienced. We also experienced, so we recommend Chrome and Firefox for this activity. But again, there's all kinds of operation system differences. We noticed some Chrome, I think maybe older operating system versions, they didn't, they weren't able to capture images. They're just capturing black, squares. In that case, our dev team recommended trying Firefox, and that worked in Firefox. There are some differences here, which we, as the team, we're trying to figure out, what are the limitations of the software here. Okay. What I can do, Karen, unless people want me to show any more things about the classifier page, I can stop sharing. And this is where Karen will take over and start some of the coding process. But I can also wait here if there's any interest in more training page related questions.
So the question was, low confidence for not me is what we want. Yes. You want high confidence when you're showing your face for me, and you want high confidence for not me when you're hiding your face. So it should recognize whether you're showing your face or hiding your face.
Exactly. Kind of like a baby, you want to be able to say, oh, this is, the face of the parent. This is parent hidden. You just want to get the correct classification and the correct confidence level for that classification.
Okay. And then we have a question, how do we see the model and data? As far as I know, some sort of XML file or something, but.
Right. So the dev team said, and I personally wouldn't dare to do this. They seem to think it's okay to actually go into these files and look what's in there. I don't know enough, so I wouldn't be confident that I'm not like messing the data accidentally. But apparently these are what is it? Are they JSONs or something like that? So if you know what you're doing, apparently you can access them. But we're gonna use them by importing the model to App Inventor, and then the data.zip, you could close the classifier, start again, and then upload the training data. So we're never gonna need to see what's really in these files. But apparently, if you know what you're doing, the dev team claims they are searchable. You could look what's in them.
Yep. And the question was, can we show the import? Yeah, we're going to actually go through the step of importing this into App Inventor.
Yep.
And actually running it.
Karen is going to take over.
Yeah, I'm going to do that. So I will share my screen now.
So I'm stopping to share. And
okay. And sorry, let me just share. Okay, so, and on the right again is what the final app will look like. So I've got it running on my phone. So if I start, it should, start to work like that. So that's the kind of the thing that we're going to build with this. Okay. So I will close that for now. So Selim covered the part where we built the model, and then the second part is then importing it into App Inventor and making an app with it. So that's the whole point of it. So on this slide, so this is slide 33, and Selim showed this a couple of times, but there's a link to this folder that has all the documents related to this tutorial. So there's a teacher outline, there's student guides if you wanted to run this in a classroom, and then we've got the AIA files, both the template that we're going to work on today, and then the completed AIA if you wanted to see it fully working without having to code it. And then as well, Selim included this peekaboo model.mdl, and that's his model that he's made previously with his face. Someone asked this question, what if someone else's face? And that's a really good thing, and that's a great learning situation in a classroom is, it may work for Selim's face, but if I then try with my face, it may not work. So you can get into the whole concept of bias in training with how, whose face is being used when you're creating a model in AI. In this folder, Selim had mentioned it before, but if you haven't already and you want to follow along, you want to download this AIA file, peekaboo_template.aia. So that's the template file. Download that to your computer. And then you need to go to the App Inventor site. So I'm assuming most people have used App Inventor before, but again, it's to get to the development. Go ahead.
I put the link, Karen, on your slide, the slide that you were showing 1 minute ago, in case.
Okay. Okay. So, I mean, if you haven't used it before, you can go to the main App Inventor site, appinventor.mit.edu, and click on this orange button, Create Apps, or it's just ai2.appinventor.mit.edu. You do need a Gmail account to use App Inventor. We also have a code.appinventor site. So if you don't have a Gmail account, code.appinventor.mit.edu will allow you to log in without a Gmail account. It gives you an anonymous return code. So if that's an issue, you can use that. Okay, so I'm going to close here. One. Now I just have to find, okay, so let me go back. Sorry about this. I'm going to go to Create Apps and go in. Okay, so from within your Projects tab, you're going to import project. Okay, so we're going to import a project. And I've got mine here in this folder. So it's that peekaboo underscore template AIA file. It will take a moment to load. Hopefully not too much longer. Let's try it again. Quite sure why mine's not.
Do you have an?
Oh, there it is. There it goes. Finally, just took a minute to import it. Some reason my there we go. Okay. All right. So as you can see, the UI has been pre-built for you. So if we look at what we have here, so at the top we have a status label. So this is going to be able to tell us when the classifier is ready to classify. So it kind of gives us a status of the classifier. Below that we have these bars, which are the bar graphs, as well as showing us the confidence levels that will report back from the classifier. Below that is a web viewer. So we're going to be taking video, and so the video will appear in the web viewer. Below that we have two buttons. One is to start the classification, so just start classifying. And then we have a toggle camera, which will change the camera to front to back facing. And then below that are our images of the happy baby and the sad baby. Okay, so those two are there. And then if you look below that, under non-visible components at the bottom is the Personal Image Classifier. So that is an AI extension. And it's included in this particular template, but normally you would import an extension here. So way over on the left at the very bottom on your components palette are the extensions. And so this one has been imported, but you would click here to import an extension. And to find that extension, I say the easiest thing to do is just to, you know, Google App Inventor extensions and just follow the links. So this takes you to our main App Inventor extensions page on the App Inventor site. And then this first one, sample extensions are at. And then it takes you to a GitHub site, but this is where all of the extensions, the Personal Image Classifier, the one we're using today, the audio classifier that Selim talked about, PoseNet, and Facemesh. So all of those extensions are here and available for you to access. So normally that's the way you would do it. You'd come down here to extension, import the extension, and you will have found those extensions and downloaded those files onto your computer and imported them from here. So I just wanted people to realize that's what you have to do. Now let's look at the Personal Image Classifier component. So if you look over here on the right under the properties, there's just a few properties for this. And the first is the input mode. So it's a drop down and the two options are video or image. For this particular app, we're just going to have it be streaming video, and it's going to react based upon whether I put my hand in front of my face or not. The minimum interval is how often it's going to be checking. And the next thing is model, and this is where we have to import our model. So you're going to click on the word none, and we're going to upload a file and choose the file. And again, I have saved my model here, but the model that you've exported from the classifier is what you'd import here, or if you weren't able to get through that, you could use the one that Selim created. So I'm going to upload that, choose that. Okay, and then the last thing you'll notice is web viewer. So this is another important thing if you're doing this from scratch is you have to tie a web viewer to the image classifier or it's not going to work. Okay, I did see the question, can this run in the emulator? Unfortunately, it cannot. So Selim mentioned that these extensions require particular hardware, and it's not going to work on older tablets and not on the emulator. And at this point, we don't have any of the AI extensions working on iOS. So that's one thing. They are, I guess, the dev team is working to allow iOS devices to use the AI extensions, but at this point, we don't. So it's just on Android and on more recent devices. I think you're pretty good with phones. Most of the phones that people own have the right hardware, but a lot of tablets that you may have in a classroom situation, you'd have to check. Okay, so what I'm going to do now is I'm going to hide these two horizontal arrangements for now and focus more on the classification, and then we'll come back to this. So I'm just going to click on horizontal arrangement 1 and make it invisible, and then click on horizontal arrangement 2 and make that invisible by unchecking it. And this is where you can see kind of better the web viewer, the buttons, and then the baby's face. Okay. Now what we'll do is we'll go over to the blocks editor. Okay, and again, the template has provided a lot of the code for you. So in a classroom situation, you may decide, I want my students to build this from scratch, and that's perfectly fine. You can give them a blank project or, less of the code filled in. But just to show you what we've got here, over on the left, if we click on the Personal Image Classifier, these are all the blocks available. So the 3 events we're going to be using are the classifier ready. So basically the app has to signal out to the classifier, are you ready to start classifying? So there's kind of a lot, it has to load the model and all that stuff. So we want the app to wait for that to happen. So that's the event that's triggered when the classifier is ready to start classifying. We got an event handler that when an error is generated. So if there's some sort of issue, that will trigger that event. And then the got classification. So once it starts classifying, it's going to trigger the event when it's got a classification. So let's just look here at what we've got. So we've got the error handler already filled in. So basically it's just going to return the error code up in the status label, which is that label at the top of the user interface. The classifier ready. So again, we have to wait for the classifier to be ready before we want the user to start doing anything. So we're going to keep the 2 buttons, the start button and the toggle camera button, disabled until the classifier signals it's ready. Once it's ready, we'll enable those buttons and they can start using it. And we're going to set the status label to say ready. And then those 2 bar labels, which we've hidden for now, but we'll come back to them. We're just going to label them with our 2 labels. And this is where you could change if you use something other than, you know, ME with a capital M and not me. This is where if you had the spaces, you could put them in here. And then the toggle camera button is basically just toggling. So there's, in the personal image classifier blocks, there is a toggle camera. So that's all that's going to do. Okay, and then the start button is, because we're using video mode and it's going to be continuously trying to classify, the start button is also going to act like a toggle. So if the personal image classifier is running, it's going to stop it. And if it's not running, it's going to start it and change what the button says. So that's all set up for you as well. So it's either going to start or stop it. And then this event is really the meat of what we're going to be doing. So this is when the classifier returns a classification. Okay, and in this case, we've initialized 2 variables, or we've included 2 local variables. And one is going to be the confidence for me. So how confident is the classifier that it's me, that label, or how confident is it that it's not me? So those are going to be percentages, as we saw in the classifier. And so we're basically going to check which one's bigger and change the baby space based on that. Okay, so what we want to do is we're going to grab this result. So personal image classifier returns a result, and that is returning as a dictionary. Selim talked about this earlier in his presentation. So what I want to do is just kind of explain what that's going to look like. So the result will look something like this: make a dictionary. And in my case, the 2 keys are going to be my 2 labels. Now, if we made a classifier that had, you know, 5 labels, it would return a dictionary with 5 keys in it instead of just the 2. And then for the value, that's going to be your confidence level. And as I said, it's a percentage. So say it's 75% confident that it's me. And the second one will apparently, the 2 will add up to 100%. So we'll have 75%. If that's 75%, the not me would be 25%. Okay, so this is what an example of what the result returned by the classifier will look like. Okay, so it will always be me and not me. It's just the numbers are going to change each time. So what we're going to do is set these variables to the confidence levels based upon the dictionary. So we're going to go back to dictionaries, and we're going to say get value. I'm sorry, get value for key. Okay, and the key that we're looking for, again, is going to be me. The dictionary is result. Okay, so result is a dictionary, and that's what's being returned. So we're going to pull the value for key me out of result, and that will be our me confidence. And then I'm just going to duplicate this and change me to not me. And I'm just going to leave this as not found. So if it doesn't find it in the dictionary, you know, you can set it to something else. You might set it to a 0, but I find that if you leave it as not found, it at least will trigger an error, and you'll see that it says not found. All right, so we've got the two results. Now we just have to check, well, which one is it? So we're going to use an if then else. So that's going to go inside here. And what we're going to do is we're going to say, well, which one's bigger? So go to the math palette, and we're going to grab an equals. And then we're just going to say greater than. And so basically, we just want to compare the me confidence to the not me confidence. So what we can do is grab, by hovering over, if me confidence is greater than not me confidence. Okay, and so what we want to do is flag that to the user. So what we're going to do is we are going to set, so we've got the two images, happy baby and sad baby. So we are going to make one visible and one invisible. So I'll say set happy baby visible to true. So if it's me, the baby should be happy. And then I will duplicate that and set sad baby to false. And then the other thing we're going to do is we're going to set the screen. We're going to change the color of the screen. So if I click on screen 1, I can set the background color. And we're going to make it blue for a happy baby, and then pink for an unhappy baby. So that would be the happy situation. So give you a minute to think about what you might do in the unhappy situation or the not me situation. But basically you want to fill in the else part of this with similar blocks.
Karen, there's a question about where did you get the set blocks? Can you maybe repeat?
Okay, sure. So for the happy baby and sad baby, so over on the left, we have to scroll way down to the bottom, but under horizontal arrangement 4, we've got happy baby, which is the happy baby image. And if you click on that, all of the set and gets for that are available. So you're going to grab set happy baby visible. And then likewise, so once you get one, because these are both images, you can just duplicate them. And, you can see that in a drop down, you can change happy baby to sad baby. And then for screen 1, also on the left, if you click on screen 1 and scroll down, all of its set blocks are available there. So we're going to set, for that one, it's going to be set the background color. Okay, and questions on the extensions? Yes, so the Personal Image Classifier, we call it the PIC extension, is included in this template, so you don't need any additional extensions. I was just showing you if you were going to build this from scratch or build a different app, you'd have to import that Personal Image Classifier extension. But for this particular app, it's included. So for the then situation, we just want to reverse everything, right? So we want to set, we'll set happy baby visible to true, and I'll duplicate the sad baby, and we want the sad baby to show up, so that we'll make that true. And then we'll duplicate the screen 1 color, and we'll change the color to pink. Okay, so let's try this out. So I'm gonna I'm going to run this with App Inventor. So I'm going to get this set up. So from Connect, and this will be where you're going to be able to tell whether or not your phone or tablet's going to be able to handle this. So scan the QR code. So the set screen 1 block, you have to click on screen 1 over here on the left under blocks. Click on screen 1, so it's underneath the built-in blocks. It's the first, so right about here, about halfway down. If you click on that, and then the set blocks will be down the bottom. All right, so I'm going to toggle the camera, And so now it's facing, so I can see my face. If I hit start, happy baby, sad baby, happy baby, sad baby. Okay, so hopefully some people were able to get that running. Okay, so that's the general idea. What I'm going to do though now is go back and add in those kind of extra features of the bar graphs at the top to give a little more visual to the user. QR code. Sure, let me do that again. So let me I'll go back. So I don't know if multiple people will be able to view this or not. Question on why is the make a dictionary not an event handler? That was merely for me to explain what it looks like. So you could get an idea of what the results look like in the personal image classifier got classification. So and anything in App Inventor, I'm just going to close that now. Any blocks that are just sitting out here get ignored if they're not inside of an event handler. So, you know, I can leave that sitting out here as a notation, or I could just get rid of it when I decide that I don't need it anymore. Okay, so just to go back to add those kind of features at the top back in, I'm going to go back over to the designer and then make horizontal arrangement 1 visible again and horizontal arrangement 2 visible by clicking on the visible checkbox there on the right. And then what we're going to do is, if we go back here, we're going to add in, so over on the left, we've got bar label 1, percentage 1. So bar label 1, if you remember, we set to say me. Bar label 2, we set to say not me. So now for percentage, so we're going to click on percentage 1 and say set percentage 1 dot text. And this is going to go above the if because this is in either case. Whoop. So set percentage 1 text 2, and we're getting a percentage, which is a decimal. So what we're going to do is grab a math block, which is multiplication. And I'm going to grab me confidence, and I'm going to take that and multiply it by 100. And I actually wanted to say, you know, what percentage with the percent sign after it. So I'm going to grab a text block, a join text block. And what I'm going to do is join that number with a percent sign. So in the second slot of join, I'll just put a percent sign. And then I'm going to duplicate that, and we're just going to do the same thing for percentage 2. Instead of me confidence, it'll be not me confidence. Right, so now when you run it, you should be able to see the percentages show up. So again, if I connect AI Companion, scan. And then the last thing after that we'll do is, okay, so if I toggle start, so now I'm, you can see that the confidences are bumping around. So they're changing as I'm changing my face, right? So again, when it's not me, it's a very high percentage for not me confidence. Okay, and then the last thing we're going to do is that bar graph. So bar graph 1 over here on the left. So there's a thing called width percent. So way down the bottom, set bar graph 1 width percent. So I'm going to drag and drop that in here if I can. And I'm actually going to just copy this. Me confidence times 100. And then I can duplicate that. My whole computer's really sluggish now, I think, from all of, and change bar graph 1 to bar graph 2, and me confidence to not me confidence. And then if I go back here now, I should start seeing the bar graph react as well.
You have to unselect, Karen, the not me block. I think it's still not registered.
Which one?
If you go to your coding environment,
yeah,
click on a white space, basically.
Okay.
Because your get not me confidence was still highlighted. So.
Okay. It's I think it's still working though. I mean, it's doing what it needs to do, I think, right?
Yep.
Yep. Okay, so that was a lot. But you can see, you know, in basically an hour, we've put together an app that we've trained a model and then included it in an app that you can use. So it's a pretty exciting thing for students, I think, when they can use something like this, train their own model and then use it within an app. Okay, so I'm gonna stop sharing right now. So, and we've got probably about, looks like about 13 minutes or so to take questions. So probably the easiest would be in the chat, but also I guess if people want to verbally ask a question, you can do that. I hope I remember how to let them ask a question. Oh, Q&A questions, yes. Sorry, I saw someone say. Okay, I want to teach App Inventor with the AI component. Will you have teacher training, say, next summer? Selim, I'll leave that to you.
So there are several options that we are working on. We're not exactly sure which ones are going to actually happen, but we have a master training program that Karen was incredibly instrumental launching. So next year, when we are doing in-person training, hopefully, that's going to be offered. We are hoping it's going to be offered in some format. We're working, and AI units are going to be a big part of that. And then there are other opportunities. For example, we are collaborating currently with personal robot groups from the Media Lab, and they have a project called Future Makers, and they reach schools from all over the country. I forgot what they're called. Is it Title IX schools? But basically schools with underrepresented populations. And this is a program where we take kids and then teachers and we train them on AI topics. So that's another way of getting involved. And I think if we just sort of follow, MIT news, MIT App Inventor news from Twitter, Facebook, etc., you should be able to get a sense.
Okay, why might I be getting this error? Error from companion, undefined variable, personal image classifier. It could be that it doesn't work on your device. Although I usually think that I do think that it would actually run, you'd just get that error, the classification error. Yeah, so you might try refreshing your screen, like refresh your whole screen. And I would also try it on a different device if you have that option.
And making sure that the model is uploaded, like, sort of like, a very common mistake that is easy to make. I made that in a Hong Kong presentation a couple of weeks ago. I completely forgot to upload the model. So we did the whole coding, everything, when it's time to testing, nothing is working and we're getting, all kinds of errors, is because I forgot to upload the model. So that, there are a few steps that are not, negotiable, unfortunately. So
yeah, that and the web viewer are kind of the things that you can easily forget. So setting up the web viewer with the personal image classifier and the model. So Amy had asked, do you have a space in not me? And that's a really good question. So I used me and not me, but you have to spell those exactly as you spelled them over on the classifier page. So this is where if you used a space, you'd have to either use a space, and I'm not even sure if it might insert an underscore. One thing I do want to show, I'll quickly show my screen, is there is a, if you look here, this is under the personal image classifier, there is this personal image classifier model labels block. So if you, and you could say like set status label text to this will return the labels that in your model. So it would give you a list of 2 items. So in my case, it will be a list with ME, comma, not me. But if you spelled things differently or didn't capitalize me and not me or put a space in, so if you're like, it's not working right, it's not doing the right thing, I would use this. And like I said, just probably do like set status label text to that, somewhere in the GOT classifier or something. And so you'd at least be able to see what your model labels are. And then you would change this get value for key to the correct words, because otherwise it's just not going to find them. Okay, any other questions? Or anything in general on any of the AI stuff that was covered?
If I could put a plug here, if I can. So we are always looking for what we're calling on-call collaborators. So we, write a tutorial mostly these days on AI, and we really need teacher input, student input. So if you would like to join that group of on-call collaborators, and I think we have a few already in the audience, some amazingly helpful collaborators. So please send me an email, and I'll send you, the survey to fill, etc. But a lot of our work really has been vastly improved due to the feedback and ideas we've been getting from the collaborators. Somebody's asking about the Scratch conference, and do we have anything like that? So this year, we did not have a summit. We normally have an in-person summit. Instead of the in-person summit, the last 2 years, including this year, we've been doing what is called a virtual appathon. So the registration closed on June 19th, but still it's available. The teams are going to be available starting this Saturday to everybody who wants to do it on their own even. And we have currently about 1,400 people who registered for that all over the world. 86 different countries are represented. So it's a really exciting event. But next year, we're hoping to return to in-person summit.
Okay, any other questions? Everyone is very welcome. We are happy to share all these different tools. I mean, we think they're pretty exciting and that kids will be excited to try to use them in apps. And certainly keep in touch with Selim through his email with any suggestions or, questions or anything. Okay, Peekaboo tutorial is not yet on the tutorial page, correct?
Right. So
Selim, yeah.
I shared it with you with a folder which has everything you would need to do a class presentation. We don't have what is called the sidebar tutorial version of that. I'm literally working on it as we're speaking. So that should be up and available definitely like by mid to late August. But that's one of the options. But the documents we share with you have everything you need, all the information you need already.
Thanks, Jocelyn. All right. I guess if there are no more questions, yeah, teaching coding virtually is not easy. But this Hopin seems to be a pretty good platform. So we appreciate the number of people that came. Pretty excited about that, and hope that you all get to try this out in your classroom. Good question, Lisa. So Code.App Inventor is, we originally created that separate platform for Hour of Code, knowing that there would be teachers that would want to try App Inventor with their students, but they didn't want to go through the hassle of making Gmail accounts for all their students. So that was the original purpose. But since then, there have been some schools where kids aren't allowed to have Gmail accounts. So it's an alternate site where you don't log in with a Gmail account. You log in anonymously, and it gives you a 16-character return code. Now, you would have to save that and make sure that you've got it, because if you lose that return code, you cannot get back in. Usually, someone forgets a password or something, or loses a project with the regular site, we can retrieve it, but the code site, no. But as long as your students, or like you as the teacher, might save the codes for your students, and the kids would just use that every day to get back in.
Super. Our good friend David Petty is here and is asking, is it possible to create your own sidebar tutorials? This is something very dear to our hearts. We definitely, as the ad team, would like to have this capability, but unfortunately not yet. It requires quite a bit of help from the dev team, and their priorities right now are not quite there yet.
But it is, it's a GitHub project, so I think, yeah, with a little prodding with the dev team, I bet we could open it up to some people. It would be great to actually get some people in the community to contribute some tutorials there. Okay, I don't quite know how these sessions end. Maybe they'll just end at 2:30 or so, but we can hang out until then.
All righty. I think 2:30 we're supposed to go to another session. Am I remembering correctly? 2:35. Sorry, 2:35 is another.
Yeah. How do we get someone to unmute? Can we? People, can I unmute them? You remember how to unmute people or not?
I think they have to send some kind of a request, no?
I think you're right. I think there's some button along the bottom that might say request. request to join the stage or something like that.
Yeah. There's apparently a keynote speaker at 2:35, so folks are encouraged, I think, to check out for them.
I'll pass on hellos to Hal from people. A few people that commented. Yeah, thanks everyone. Okay, I think we can probably leave. I think has everyone left?
Okay, so we'll see you tomorrow, right, Karen, for the Technovation
Yeah, I'll
meeting?
see you at 10 o'clock. Yeah.
Looking forward to it.
Yeah, should be good.
Alrighty, pleasure as always. Take good care.
Yeah, you too. Bye, everyone. Thanks for joining us.